fun too. A 3D printer is a great tool that enables makers and DIYers like yourselves to create objects and prototypes and functional working objects that's very easily and quickly. There are three basic technologies that 3D printers use. The first one is FDM, which is what my 3D printer here is. Hold on. Okay, now it's on. So the first technology that 3D printers use is FDM, or Fused Deposition Modeling. The way that works is a 3D printer will take this plastic filament and then the motor will push it into a heated nozzle, and the nozzle will melt that plastic onto a build platform to create the object. In this case, I'm making a whistle. The second technology is SLS, or Selective Laser Sintering. The way that works is there's a bed of powder, there's a powder bed, and a roller will go across, deposit powder, and then a laser will then melt together or sinter the powder to create the object. The third type is SLA, which instead of using a powder, it uses a UV curable resin and uses a UV laser. But the one issue with commercial 3D printers is that they cost a lot of money. Like, the cheapest commercial 3D printer is an FDM one, which is made by Stratasys, and it costs around $20,000 plus. And while it has very high resolution, it's out of most of our budgets. That's why I have this MakerBot, which is a great 3D printer that costs only $1,299, and it enables a maker on a pretty limited budget to make things, and it's also a great tool. Like, there's this one person in that he washed his pots and he needed a pot holder. So instead of going to the hardware store and buying pot holders, he 3D printed them. And the great thing is that a 3D printer like this is really inexpensive to use. So a 3D printer is a great tool for inventors because it lets you test the design very cheaply. And the other thing is that it's relatively fast. To make a whistle that's about this tall, this big, it takes only about 15 minutes. For larger objects, it can take more time. And so if you want to print something about this tall, this big, it takes about an hour. And that's pretty quick compared to sending your design off to some company in China or wherever to then have them make it and ship it back to you. It can take many weeks. With the 3D printer, it then enables you to create a prototype very quickly and easily, or create a replacement part for something that broke. Like, another great thing is that there's Thingiverse, the universe of things. It's a great website that has a bunch of different things you can do. Like, it has a turtle shell eraser. It has a printable padlock that actually works. It has all these great things. It has this whistle that I'm printing now. I got it from Thingiverse. The best part about Thingiverse is that instead of you having to design it yourself, you don't have to do something redundantly if it already exists. The other thing that Thingiverse lets you do that is great is it lets you create derivatives and mashups. A mashup is when you take two things on Thingiverse and you mash them together to create an object. A derivative is when you take a part and modify it. Let's say the knob on your stove broke. On Thingiverse, they already have a stove knob, but your stove knob might need a different mating connector to go on the stove. So you can go on Thingiverse, download that stove knob, then upload a derivative of it, which has a different design so it works on your stove. So now if someone else with the same model stove or a stove made by the same manufacturer, they don't have to modify. They can just go on Thingiverse and say, oh look, there's a derivative already here, I can download and print that. A 3D printer is also great because you can use it to create toys and other custom things. Like the store, you go to Thingiverse or some other website, and maybe instead of downloading something for free, you might have to pay for it, or it can be free depending on what the maker chooses. But that way you can do it in your own home, and you can have much more control. Are there any questions? Yes? How much would it cost for the material to make a whistle? The whistle costs about 10 cents, I think. This plastic is actually really cheap. About one kilogram of it is about $45, and you can print a lot out of 1 kilogram. Because what happens is if you're putting a cube, you can actually control something called infill. Infill is the amount of plastic it puts down, and that's a percentage. So if you do 100% infill, completely filled in, it's really strong, that uses a lot more plastic. If you do 20% infill, it's still pretty strong, but uses less plastic. What it'll do is it'll do either a hexagon or a square shape to fill in it, so it still uses it. Any others? Yes?
How long can a Thing-O-Matic usually go before it breaks?
How long can a Thing-O-Matic usually go before it breaks? What do you mean by breaks?
Stops working. I'm assuming you can repair them, right?
Yeah, the great thing about MakerBots is that they're all open source. So if you have a laser cutter and maybe you buy some of the parts from MakerBot, like the steppers and the control electronics, you can laser cut this and make most of it yourself. And the other thing is that since it's open source, if something breaks, you can, let's say that something on this piece of your automated build platform cracks. Or actually, let me do a better example. This side piece here, you can't print anything without that side piece, without that side piece. So what you can do is you can then go on Thingiverse, download that file for the Thing-O-Matic, and if you have a laser cutter, or if you don't have one, you can go to Heatsink and use theirs. You can then put in acrylic or wood, but I think wood will actually snap under the tension. You can then laser cut a new part and put it on, and you don't have to pay for that. All you pay for is the material. Yes?
How long does it take to print something?
Example of how long does it take to print something? It depends. This whistle here takes about 15 minutes. The larger you get, the longer it takes. The other thing is that you can print infill, which is you can make it more hollow on the inside, so that way it uses less plastic. Any other ones? Yeah? The kind of plastic it can use is ABS, which is the same thing Legos are made of, PLA, which is made from corn and it's biodegradable, and MakerBot, they recently released PVA, which is polyvinyl alcohol, and it is actually plastic that dissolves in water. And they also recently released their new Mach 7 extruder, which actually is much more compact than this. It's probably total size is about that big, and with that right below it, and it's small enough that you can have dual extruders. So you can use PVA and either ABS or PLA, so you can then actually make an object that, let's say you want to print something with an overhang or where the plastic sticks out and is unsupported, you could put PVA in that second extruder, so it prints something to hold up that overhang, and then print either ABS or PLA in the first extruder, and you can then, once you print it, you then drop that in water, and the water will dissolve the PLA while leaving the PVA, while leaving the ABS alone, so now we have just the object. Yes? Yeah, it's actually hollow on the inside, and it will yeah, it also prints a ball inside. The way it does that is it's connected by a little piece of plastic. The way it prints the top is that there's a the way it does it on the whistle, it does a bridge where it goes from one side to the other side, and it actually drapes the plastic along. And the plastic is elastic enough that it will stay together. Yes?
Are there any settings on the Thing-O-Matic that you need to adjust, like how hot the melter is? Or anything like that?
Are there any settings on the Thing-O-Matic that you need to adjust? Yes, there are. The settings actually, they aren't in the Thing-O-Matic, they're on the computer. What you do is you take a 3D model and you use it to generate G-code, which is a text file that are instructions for how the printer should move and how fast, when to start and stop extruding, and what temperature should the nozzle be. You can modify all of that depending on what your needs are. Like PLA has a lower melting temperature than ABS, so you'd reconfigure the settings for PLA. I'm not sure about PVA, so I didn't do that for that. Also in SkyForge, depending on the nozzle that you use, MakerBot sells from 0.3, 0.4, 0.5, 0.8, and 1 millimeter diameter nozzles. So you can actually reconfigure your settings in SkyForge depending on what nozzle size you use. And also, another thing to do is change the feed rate, which is how fast that the printer moves, the flow, and you can also control the number of cells it does, which is how many times does it go around the outside before it starts doing the infill. Yes? The maximum dimensions of what a Thing-O-Matic can print is about 110 by 110 by about 100 to 120 millimeters for the Z. The reason it varies for the Z is that the MakerBot Thing-O-Matic can actually use up to it has two different build platforms that come as the kit by default. The first one is a heated build platform, which it's like the automated build platform, but it is just a heater. The second one is the automated build platform, which has a conveyor belt and a motor. So if you want to print 50 whistles, you take the G-code file and you copy and paste it 50 times, or you can do it, or you can just do it 10 times and click print every time it does 10. And you can then put a bucket here so that when it's done, the build platform, it automatically goes to the front, and this motor will turn and it will knock off the part into the bucket. And the reason it varies is because the motor takes up your Z space, so that's why it's like that. Any others? Yes? What? Is there a chance of it overheating? It could overheat, but because they actually have a cartridge heater, which is designed for heating, because before they did the Mach 6 Plus, which is what I have, they had the Mach 6, and it uses 2 heater resistors, so if you overheat, the resistors will break and it won't heat. Now with the cartridge heater, it can heat hot enough to start a fire. So what it does is on the side here, there's this little circuit board, and what it does is this black thing here, that is a thermostat. What happens is that this is set for 140 degrees centigrade. So when this reaches 140 degrees centigrade, which is when this goes to about 270 degrees centigrade in the nozzle down here, the thermostat will then open, and this relay here, it'll then open, and someone has to manually go and reset that board for it to continue printing. And this also has this cable here that goes down to the motherboard that is connected to the emergency stop pin that will actually shut down the printer. Yes? How many pieces does it need to work? I don't know the exact number, but it's probably over 100 pieces if you include all the nuts and the bolts. But it comes as a kit. MakerBot actually released a new option for them to assemble it for you. But it's actually pretty easy to assemble. The assembly instructions are very well documented on their website. Yes? this as a kit from MakerBot, and I assembled it. It took me about 2.5 to 3 days to make it. Any others? Yeah? What are some of the things I've made? I've made octopi, whistles, I'm working on making a turtle shell racer. What else? That's mostly what I've made. Anyone else? Yeah? What software do you use if you want to design your own cars? You can use just about any software that exports an STL file. Some of the softwares that you can use Google SketchUp, which is Google's free software. You can use OpenSCAD, which is a text-based 3D modeling software, and instead of having a GUI where you like do a sphere and you draw it, you type in sphere, open parenthesis, the size you want it to be in millimeters, close parenthesis, and then that's how you do it. There's AutoCAD you can use SolidWorks. For Google SketchUp, you do have to install a plugin to export an STL file. All the other softwares I listed I know have native STL software export capabilities. Anyone else? You have a question? What can it make? It can make almost anything you tell it what to make. You can have it make toys for you. Anyone else? Yeah? How much of the MakerBot can it print itself? Oh, it's done. So currently it can print. Currently you can't print the Thing-O-Matic on it by itself, but on Thingiverse, the older model, the Cupcake CNC, there is a thing on Thingiverse which is how to make it. Like you can print a cupcake CNC out, but currently there isn't a printable Thing-O-Matic. But you could be the first person to make a printable Thing-O-Matic. Anyone else? Yeah?
Does that whistle work?
Yeah, I just need to, there's actually a ball inside it. Let me snap it out. Any other questions? It's not finished. Are there any other questions I can answer while I work on this? Okay, I'll work on this. Thank you.
It's got a 3D ball printed on it, but it has to be attached.
I guess it works without the ball in it, without the ball completely let go.
Do it again!